take the stage. Luís Bettencourt from Santa Fe, already known to us. Nadya Komendantova, she is working at IIASA. Nadya, are you here somewhere? Yes, she's here. And then Martin Lies. Martin Lies is a new face to us. He didn't speak yet. I can assure you that he will speak now and you will listen to him because he has a message to tell us. Raya Muttarak, yet another, we call it mid-career researcher at IIASA, is in the population program. Steve Robinson from our partner club Informs. Don Saari, IIASA Council Chair. And Peter Sloot from NTU Singapore, yet another partner to IIASA and to all others in this wonderful conference. We will start by asking you to give a very brief, and you understand why very brief, pitch on what you would see, not looking back, but what you would see as a one single, not two, one single major key challenge in getting either methodological question tackled and solved, or science policy question tackled and solved, or policy to science question tackled and solved through what we call system analytic approaches. Before I do that, I would like to say a few words in which I would like to draw a little bit the landscape we are at. When Don and I, frankly, discussed this opportunity, and then of course I went to IIASA staff and we discussed a lot with all program directors and with Elena and Ulf and all the others. We said, let's have a conference which will be giving a lot of focus, a lot of room to the methodological aspects of system analysis. And I think we succeeded. But you know, when you have a success, then you think, well, of course, methodology is fundamental, but there is also so much which is going directly to the policy application. So we haven't really done that much at this conference, looking into the success and lack of success in science to policy communication. And I would like you to consider both in this panel, to see what kind of next challenges we should address in that second field. And I will tell you in the end what kind of thinking we have developed listening to all of you about that second part. So I will start, I will go like this, not random. So Don, you are first to give us, say, max 3-minute pitch.
I stand between us and wine, so it's going to be...
and good wine and good dinner, just be patient.
Dinner, so it's got to be short. What do I view as a major challenge? I think, and this is something that I've been talking with Alexei a couple of times, and that is the challenge of making systems analysis into a science. Now, what we have is, if we could do this, what would be the objective? Well, I've been thinking about this for a long time. And in fact, that's what led to my introductory comments that rather than the whole is the sum of the part or the whole is larger than the part, I really believe that the whole is the interaction among the parts. That's systems analysis. And in this spirit, I think that a science of systems analysis would be something that would achieve the well-being, that when we're trying to achieve the well-being of a system, that the way we do this is we're trying to understand how the parts interact. And if you listen to the wonderful summary that Elena and Ulf did, that's what they were talking about. They were talking about the different characteristics of the parts. To tie this in with the wonderful lecture we heard last night, and wasn't it wonderful? It was great. One of the best I've heard of a public lecture. What happens is, after he reminded us about Turing. And after Turing, then all sorts of specialized computers were developed. Now, these specialized computers, what did they do? They truly made advances in each of the component areas. But they did not make an advance across the board. And that was von Neumann's insight. It's that really what they were doing is they were ad hoc. They were specific for a particular area, a particular project. But they were reinventing the wheel each time they went around. And so his idea was that maybe we can avoid the need to reinvent the wheel again and again and again by coming up with an architecture so that when we see a new project, when we see something that has to be done, that what we can do is build upon these foundations, which has this commonality. Now listen to what we did here at this wonderful conference. What we did is we talked, and you have to admit that we're talking about a large number of ad hoc techniques, much like right after Turing. A number of ad hoc type techniques that are really making advances in particular disciplines. But as we've heard, just even with the review we had just right here, it is not across the board. And so what there really is truly is a challenge to try to find what are the characteristic parts. Now can this be done? The answer is yes. I've already started working on some of these type things, and it's not easy, but there can be type things on here. But because my comments stand between us and wine, I'm going to summarize it with the final statement that all of the ad hoc, what's the commonality? How do we pull these things into a theory, into something that we can teach, rather than this ad hoc method, this technique, that technique, that we have the 10 items that we heard coming out of this conference, and they're all special cases of an overall theory. Can this be done? Yes, it can, and it must be done. With that, I quit.
Thank you, Tom. Thank you. Martin.
Well, thank you. I have to say, first of all, thank you for inviting me, because I don't live in this world, and it has been very educational. I've learned a tremendous amount. So thank you very much. Ladies and gentlemen, if we're honest, we recognize that the world community is facing a perfect storm of connected challenges on a scale that we have never known before. And yet we are failing to deal with them properly and intelligently. We poke at these systemic problems with reductionist, narrow, partial efforts which are disconnected. We react to the problems rather than looking ahead and anticipating them and having some vision about what we should be doing about them. So we're failing to anticipate, and the results are very worrying indeed in many, many fields. I am working on the interface of policy and science, specifically in the field of climate. And if you look at what we have achieved in the last 20 years, while we have been talking, emissions have risen roughly 65%. So we're not really making a good effort to solve this problem. Paris is unlikely to solve the problem. The current assessment is that if the INDCs are actually implemented, we will remain on a path towards roughly 3.5 to 4 degrees temperature rise. And may I remind you that that figure is a global average figure, which means 2 or possibly more times that in the Arctic and in the West Antarctic and such like. So we are in serious trouble, but we're not acting intelligently and effectively as a species to deal with the damage we are doing to our environment. So rather than talking further, let me flag 4 particular lines of action, you asked me to do that, which could help to resolve this problem. First of all, what I would say is the tools and insights of systems thinking are actually relatively simple, but 99% of people don't understand them, including the people who are negotiating on the climate issue. We have diplomats, we have lawyers, we have all sorts of intelligent, well-meaning people. They do not have the intellectual tools to understand what you mean when you say we're at risk of non-linear breakdown of some of the climate systems. We have, therefore, to convey the tools and insights of systems thinking to a wider audience and get out of our silo and get these ideas out there. Secondly, we need to organize coherent briefings for leaders, not on climate, because climate is a symptom of the way we are running our economies and our societies. This is where the systems is so vital to position climate not as a standalone environmental issue, but as part of a bigger picture. Thirdly, the education system is producing precisely the wrong type of people to deal with the kind of issues that we face. Curricular and methodologies have to change to produce a new generation of leaders who can understand and act on systemic problems. And finally, I would say the real issue of climate is not something for future generations. It's hitting people in the developing world right now, hundreds of millions of them. And they need help. Adaptation is local. They need to know how to handle these problems in their own contexts, and we can do that by transmitting to them the skills and knowledge related to systems thinking. Thank you very much.
That's for both speakers. By the way, this said the man who was Undersecretary General, who was advising Chinese government G20. Martin, I will come back to that, but system thinking language to those big fora. I will ask you a question later. Why did we fail having such a great people like you in the system last 20 years? I will come back to you. Luís. In a minute. Just Luís now.
So I want to take it from there, and I think, but I want us to also shift the frame a little bit. I think it's essential that we realize all these problems. There are the problems on the table for us as citizens, but also as scientists. But I think, as the tweet said, we really need to focus on the solutions, and these solutions need science if we're going to find solutions on the time scale that we wish for. So just to focus our attention, if we think about the Sustainable Development Goals, we're talking about 15 years to achieve something that humanity is wanting to achieve ever, right? So if you look 15 years ago, it's 2000. For me, it doesn't feel like it was a long time ago. So it's really a very short amount of time to do a lot. And that's only possible if we have very good knowledge about how to act. And this is a central role for science. So to answer the main question, what we need is a real science of sustainability that works and that can deliver to these problems. That science, that body of knowledge, which goes beyond science, is going to be different from what we've had in science before, and even in the science of systems and systems dynamics that we've had before. Because what you see is that a lot of this knowledge, the facts, the data, the organization of this knowledge, the analysis, is being done by communities in technology, in activism, in science for sure, in policy. And these communities, to your point, have been very disconnected and therefore susceptible to gut feelings, impressions, instincts. And what we need to create also is an infrastructure, both of knowledge, but also technology that allows us to agree more and to focus on problems and perceive tangible change that we can act on and on which we can build knowledge. So to me, that's the challenge. And if we can do anything like that, it will be extraordinary, and I look forward to contributing to it.
Thank you. Nadya.
I would like to pick up to this previous discussion by speaking about the challenges to systemic analysis in such areas as risk governance, for example. One of the major of them is a co-production between knowledge and praxis, is this process of transfer between science to praxis, which is influenced by several cognitive and behavioral biases, by different risk perceptions, by different institutional structures and interests of stakeholders. We also need to understand the usability of decision support tools and how to involve the stakeholder feedback into the further development of these decision support tools. The second challenge to me seems to be that this process is not a one-way process, but it's a two-way process. Also going back, so how actually to involve stakeholders, how to address the concerns, the level of acceptance, awareness, their willingness to participate, for example. This seems to me to be two major challenges.
So two-way interaction partnership, thank you.
Two ways and partnerships, exactly.
Raya, you are at IIASA and you are mid-career, high potential. You have heard all these things. Tell us, what is your biggest frustration with all these things?
In my case, I would like to take a perspective of a social scientist or a sociologist, to be precise. We have heard already many times in this conference about the importance of integrating socio-economic elements and psychology into system analysis. And indeed, I think social and behavioral science, we have methodological tools, we have data, We have knowledge on human behaviors and institutions that are ready to be incorporated into system analysis. And there have been a lot of improvement in the quality of the data and the coverage in terms of time series database, for example, that allow us to compare the changes over time. In our work, for example, we have used the emergency event database, which records all disasters in the world from the year 1900, so we can project, we can estimate mortality data according to different SSP scenario, for example, and there have been also an increase in the survey data at the individual level, which is, I think, this is where social science come in, because we know we can estimate in a systematic, empirical way the changes in behavior, in attitudes, in perception. So this is type of thing that is already ready to be used, and we are ready to contribute. So I just want to say that don't be afraid to talk to sociologists, because we can count. We do some modeling, maybe not too complex one, but I mean, we can't.
Thank you, both of you. Now we are going to two co-fathers, in this case co-fathers, and there is some co-mother as well, still Robin, right, of this conference. So informs, what is your take on this complex issue and on our shared sense of frustration we are not making enough progress?
Well, I certainly want to say first that this has been a very impressive conference. I've learned a lot. And everything that I've heard from the speakers has suggested that we're going to need a lot of systems analysis to deal with the problems we're facing. Now, if you want to get a lot of systems analysis, you're going to need a lot of practitioners who understand how to do it. I have not heard discussion about how we're going to prepare the people that we need to go out and do these things. Now, let me just say a little bit about some of the things that are standing in the way of that. And I'll speak for the United States, because I think things in some ways are considerably ahead in Europe with respect to systems analysis. But for, say, engineering schools in the in the United States, the education is of high quality in engineering. There is basically nothing in the curriculum of most programs that would prepare such a person to do the kind of thinking and to work with the kind of people that need to be worked with to handle all the aspects of a really difficult problem. I think this is a major problem, a major difficulty for us. It's going to be something that is not easy to solve. As an academic, I can say with confidence that academics will not change unless you push them very hard. I don't know how to push them very hard in this case, but I would suggest that it's something that we all ought to be thinking about.
Thank you, Steve. And I think, thank you for honesty and for self-criticism, because we indeed are part of the problem. Academic enterprise is part of the problem. Peter.
Yeah, so I also enjoyed very much the different talks. One thing that actually came to my mind is what we are seeing is this merger between system analysis and complexity science. And that is needed. If we really want to incorporate social processes into the physical processes and all the things that are going on in, for instance, coupled human-natural systems, we do need this integration between complexity science and system analysis. Now the problem, and there are many, the problem is complexity science, we don't actually know what it is. There is no theory of complexity. It's not there.
Is there a one for system analysis?
And what we heard from the first speaker is actually there is no science, as you want to call it, whatever, of system analysis. So that's a real problem. You have a science, you have no science, and you have no theory, and you want to combine these things. And we need to combine these things, and then hopefully get something that's better. Of course, big data is going to help us a lot in getting patterns and trying to find those patterns. But what we also need to realize is that big data will induce much more exceptions than actually rules. And so big data is not very helpful in many, many aspects of the things that we try to cover. And there's another thing, and that's I think that is overlooked very much. In complex systems, many complex systems, if not all, have a thing what we call scale-free behavior. And that means that there is no mean, there is no average. There is or it's 0 or infinity, but there is no real average because it's scale-free. And that means that all your machine learning algorithms will fail. And that means that big data is not going to really help you in understanding complex systems. So I think there are, maybe this is a bit of a sobering thought, but I think there are huge challenges ahead, even though there is a tremendous progress, which was shown in this conference, but I think there are huge challenges ahead in deeper understanding of what these complex systems are and how we can connect them to system analysis.
Thank you very much. And I would like to give a hand to last 2 interventions of 3, 2. Now this perspective and outlook for a very short term one, for the wine and a dinner of course is lurking, so we couldn't go for too long. But I would like to ask you a question without pointing at anyone to answer it. And this is something which we try to think about when we go home and then think about what we have done last 3 days. Do you believe that anything would change in the world after this conference? And if so, what? Okay. Do you believe that anything would change after these 3 days in the world of any kind or not? And if something changed, what do you think we actually achieved here? Don't give me a long story, just one thing. Who wants to speak to this effect? That's okay. Thank you, Martin. I thought we will be very depressed if nobody speaks.
I think whether anything changes depends on what you will do. Frankly, I throw the ball back to you.
I think what we will do, listening to you.
Because IIASA is a remarkable institution. It's a lighthouse on systems thinking across the world. And if you choose to mobilize new forces and widen your perspective, as I suggested, if I may say, then I think a lot will change. If you can educate large numbers of people to understand how to use these concepts of multidisciplinary thinking, longer-term analysis, risk management, these are vital questions which we're not applying to world problems. So I think if you at IIASA choose to move ahead, building on this remarkable conference, something will change.
Thank you very much. Of course, not only us, we are not without reason sitting here together with Informs and Santa Fe and Complexity Center in Singapore. So, of course, our hope is, and I will say it again by the closure, that we will stick together to this absolutely fundamental mission. Somebody else has an idea about what we achieved? We go, okay, that's going well, right? Better.
Well, maybe just a small remark adding to this. If we really want to have these changes to happen, education is indeed crucial. But we need to realize that all the funding, most of the funding that is still, for instance, in Europe being spent on science is monodisciplinary. All these scientific evaluations are taking place by monodisciplinary panels, and all our education is still monodisciplinary. So as long as we don't solve these 3 hurdles, as long as we don't really seriously invest in multidisciplinarity across these 3 scales, so that's the evaluation, the money that's being spent on it, and the education, as long as we do not do that, we have a tremendous problem, and then we will not have an effect of this conference. So if this conference can actually contribute to spreading that idea, I think that will be very much
Thank you, Peter. This is such a fundamental comment, and I mean, as a matter of fact, IIASA is trying to put something together which is called School of Excellence, where we will approach you as a partners, because we believe that the biggest hole in the system is mid-career, tenure track. We screwed it up, I'm sorry for terminology. We put these people into the silos, and we need to change it, right? Thank you very much. Raya.
Yes, I would like to compare this with when we do recycling. Like when you separate the plastic and so on, do we believe that it's going to change the world, or just one action of each individual? Maybe it does, maybe it doesn't. For the outcome of this conference, I guess we could probably even monitor the interaction or how we change the word through Twitter, for example. That could be things to analyze. What kind of networks that we have created through this conference. And I guess it would change maybe in a smaller scale, and then, I don't know, when's the next conference? Then we could observe bigger change.
Thank you, thank you. Anyone else to contribute to what we have achieved? You think what will be really the game changer, smaller one, little one in the world after this conference?
I think that during these 3 days we had several topics which were directed directly on the change, such, for example, addressing the issues transformative, integrative, participatory. And also by speaking about education and the level of awareness, I think that this conference created a certain level of awareness in the need for the new methods of systems analysis and interdisciplinary thinking, which was distributed not only here among the participants of this conference, but thanks to the new media, new channels such as social mass media. So probably these impulses which would be created today, like seeds, would be growing in the next years among young researchers and among established researchers and policymakers.
Thank you very much. I would like to ask the panel to stay on stage, and I would like to say that we are right on time. It's incredible, but it's 7 o'clock, so let me use last couple of seconds of maybe 1 minute to say a few words and to close. I will go to this microphone. I'm sorry to put you in such a challenge all the time. And first, of course, thanking the panel, thanking for coping with time, but also giving us very concise, valuable information about how they think about Outlook. I think that we achieved a lot. We achieved a lot of learning, a lot of understanding. We achieved a lot of thinking about future plans. And I'm going to make here from this podium to all of you a promise that we will live up to expectation which Martin put us in front of us. IIASA, together with partner, will be working tirelessly on this mission. Mission which was defined by many of you, different definitions of the system interactivity, the way how science policy should work. Frankly, because of 2 reasons, or maybe 3. First, we have no much time to wait, as said by many of you. Second, we simply know too much not to be able to communicate some of it to the policy-making process. And third, at least for me, we are driven by a healthy portion of frustration. Frustration of lack of progress, frustration of looking around and failing every single time to communicate the message to those who decide about how this world would look like in the future. So my promise from IIASA side, and I think it goes for Chair of the Council, Don, that we are going to work tirelessly on that. My call on you to stay with us on this mission. My call on our partners, Santa Fe Informs and Center of Complexity in Singapore, to stay on this mission. We would like to have this conference, this meeting, this working space, this workshop, every 2nd year. So this is the first one in the series. We will try to keep connectivity by having these little projects together. I was very serious when I suggested that after this excellent summary by Ulfa and Elena, we are trying to put together a kind of review paper together with all of you. If CERN can publish paper about one single Higgs with 2,000 authors, why not bloody hell all of us about system analysis, right? So that's what we should do. Now, I'm going to do a lot of thanking during the dinner, so I'm not going to do it here. Just one exception. And this is these boys, they are all of them boys, sitting there behind. I think the quality of the conference, quality of sound and picture, quality of communication was simply superb. Here on the web, on the YouTube, on the Twitter. So I would like to ask them to stand up and you join me giving them big thanks and hand. And now is the time to go to catch a bus and to explore the systemic properties of the Austrian wine and food. See you there. Thank you.